Okay, so this graph, we've already kind of talked about what the stuff is on a velocity graph. If you're in physics, you've also talked about it already before. I just want to talk about it one more time. Hopefully maybe one of those times it'll click for you. So if this is your velocity graph, I've got minutes on the x-axis, miles per minute on the y-axis there. If I was looking at everything above the x-axis is when you're moving in what direction? Positive. So you're moving in the positive direction, or another word that you might see if you're above the x-axis would be maybe going forwards, or sometimes in your calc homework you might see that you're going right or up. Okay, all four of those words are kind of different words to describe the same thing. If you're above the x-axis on a velocity graph, that's kind of what's happening there. Which means that if you're below the x-axis, what's happening? Where are you moving? Down, negative, backwards, and left. Okay, so that means I've got how many different places on this graph are we turning around or changing directions? How many places are we changing direction? Not quite 4. Just 2. I go from positive to negative, and I go from negative to positive. So I'm only changing directions twice. Okay? That in yellow. Okay. Up here in red, I have when you are moving away from 0, what is happening? So like that means here I'm moving away from 0. Here I am moving away from that x-axis there. I'm moving away from this x-axis here as I go towards the right. What's happening at all 3 of those points, or all 3 of those sections? We're speeding up, okay? We're speeding up. When I kind of talked about it, I talked about when your velocity and your acceleration match, right? The signs have to match. And then that means all the places where it's moving towards 0 or towards that x-axis, so here, here, and here, all of those values we're going to have speeding, or sorry, not speeding, slowing down, right? And that's because my velocity and my acceleration have different signs. Okay, because remember, if you're given a velocity graph and you want to find the acceleration, you're looking at the slopes of all of those values. So if I look at the slope of this first blue section here, the slope is negative, but my velocity is positive. So those two things don't match, therefore we're slowing down. Okay, sound good? Cool. All right. Oh, and last thing here, what happens when I have a horizontal line? Yeah, it's a constant velocity, right? Yeah, or if I took the derivative of it, right, the acceleration would be 0. Yes. Okay. So my distance, if I wanted to know how far I traveled in total, okay, how far I traveled in total, I've got these values of 10, 7, and 5 on the graph here already for the area underneath those curves. What would my total distance traveled be? Total distance traveled. 22. We add all of these 3 things together because no matter if I'm going forwards or if I'm going backwards, if I'm going forwards again, right, that distance that I traveled still happened, right? So the distance traveled would be 22 in this case. What about my displacement? Is it 0?
No, wait. 8.
It'd be 8. Because I'm taking 10, I'm subtracting the 7, and then I'm adding the 5. Because I actually want to know where did I end up, right? If I go forward and then I go backwards and then I go forward again, where did I end up from where I started, okay? In integral form, what that looks like for distance, that means you're taking the integral from whatever values of the absolute value of your velocity function, and that is what your distance is, okay? We added up all those areas to be positive, so that's your total distance. for displacement, what would I change about what I wrote there for distance? Any ideas? How would I change this integral to be for displacement? The absolute value. I would just take the absolute value out. It would just be the integral of our velocity function. And that's it. So distance is your absolute value. Displacement is just whatever it is. If it's above, it's positive. If it's below, it's negative. Okay? Do we feel a little bit better about this if we were feeling a little unsure, hopefully? Yes? Okay, great. All right. We're going to start with our non-calculator example then, which is going to be kind of a good segue from what we were just doing, because we just had a graph that looked like this on the previous page that we were talking about, and now we're going to answer some questions based off of it, okay? We've got a space shot here. How many of us have ever ridden one of those roller coaster things that just goes up and down and up and down and up and down? Do we like that? We like that? No, I can't do that either. Do we like the spinny ones? Roller coasters? No? You're just not a roller coaster person at all?
I love roller coasters. I like the loops.
Oh,
I like
okay.
the spin.
That's fair. That's fair. No spins for anyone. Okay, I like it. I can't do either of them anymore. But this space shot amusement park ride, basically, this is the velocity function for it, okay? So, first question that we're asked is, what time, if any, does the space shot change direction? And then give a reason, okay? Where is it going to change direction? I heard us all kind of whisper it. 6, 8, and 10. Okay, so we can say at time t equals 6, 8, and 10. And what is our reasoning here for this? Why does it change direction there? Yeah, because it crosses the x-axis. But even more specific, it's because my velocity changes sign at that point. If you're taking the AP test, they're going to want something more specific as this. If you're just going to answer it for a test in here, I'm okay with the, because it's on the x-axis answer, that's fine. But this is a more accurate answer of what's going on. It's because that's where your velocity is changing signs, from positive to negative, negative to positive. Okay, we're going to talk about B here in a second, but I'm going to skip that and talk about letter C. Letter C says to find the total distance the space shot has traveled during the time interval from 0 to 14. So we're given the velocity function. How am I going to find the total distance? Total area underneath the curve, right? So what we're actually finding here is we're finding the integral from 0 to 14 of my velocity function, but the absolute value of it, because I don't care where I started, where I ended, right? What I care about is how far up, how far down, add all of those values together. Okay, so what I'm going to give you right now is I'm going to give you a few minutes. I want you to go back up to your graph and find all of your areas underneath the curves and see if you can't find what your answer is, okay? So your areas underneath your curves should have been, this first part is a total of 100. Oops. This next triangle, how much is that next triangle underneath? 60. Next triangle is 40, and the last one is 80. Okay, so those are all the areas underneath the curve. So that means for my distance, the total distance that that I traveled, if I add all of those things together, I end up getting 280 feet. Okay. All right. Reason we skipped to part C is because we need all of those area formulas to use to solve for part B anyways. So it asks us at what time is the space shot the highest and how high is the ride at that time. If you guys remember this thing, there was this thing called the candidates test. Do you guys remember that phrase at least maybe? Yes? Okay, the candidates test says that we need to test all of the values that where like the velocity is equal to 0 and also the beginning and end point. Okay? Now, if we think about this a little logically, okay, this one has a little bit of context, so it kind of makes sense, right? If we're riding this space shot roller coaster, where do we normally start at? The ground, so 0, right? So it's definitely not going to be the highest at the beginning. What is it going to be at the end after I've come back down? Also 0, right? So technically, we already kind of crossed 2 of them off the list already because we know that if I integrated from 0 to 0 of my function, I get 0. Same thing if I integrate from 0 to 14 of my function, I also end up getting 0. Okay? Notice the difference in notation. There's not an absolute value bar around this. There was an absolute value bar around this one. Okay? So this is actually your displacement, where you started versus where you ended, right? That distance between that is 0, which should make sense, right? Yeah. You're not getting off at the top. Not at this roller coaster, at least. Okay? So now I got to check my other values. We got to check from 0 to 6. I need to check from 0 to 8. And I need to check from 0 to 10. So if I go back up to my picture here, this first one here from 0 to 6. 0 to 6, the area underneath that curve is 100. So therefore, this would be 100. If I go from 0 to 8, this is a positive 100, but then a negative 60, right? So 100 minus 60, that's going to give me 40. So I know this whole thing is 40 up to 8. And then I have another 40 that I'm going to add to that. So 40 plus 40 is going to give me 80. So where is the space shot the highest at?
0 to 6.
Not 0, 6. At time t equals 6, right? So the space shot is the highest at time t equals 6 seconds. At a height of 100 feet. Part D is kind of just a check to see if we know what acceleration, velocity, and distance looks like on a certain time interval from this graph that we're given. So it wants us to write an expression for those three things on the time interval from 10 to 12. So I'm looking at this specific time interval right here. So if I wanted to find the acceleration of that highlighted yellow piece there, the acceleration, what would I do to find acceleration if I'm given velocity?
Derivative.
Take the derivative, right? Which means find the slope, right? So if I was finding the acceleration for this point, that would be from v of 12 minus velocity at 10 divided by 12 minus 10. Which we could actually evaluate. What is the slope at that point? If I go back to the graph. Check that y-axis. I think it's negative 20, right? Technically. So technically this would equal negative 20, but it asked us for an expression. So I'm going to leave that expression up there as well. But that negative 20 is what the slope is in that segment, which we're going to need here in a second anyways. Okay? So now it says I want an expression for velocity. If I want to write an expression for velocity, we're already given the velocity function, right? So how could I write an expression for this little segment right there? How could I write the equation of that line?
Y equals mx plus b.
Y equals mx plus b. I know my slope already, right? I just found my slope. My slope is negative 20. I have like 3 points right there, right? This point, 10 comma 0. This point, 12 comma negative 40. So I can pick either of those points and write my equation. So my equation would be, I'm going to choose this one just because there's a 0 in it. And that's a little nicer. But that would be y equals negative 20 times x minus 10. So my expression for velocity on that piece is negative 20 times x minus 10. Obviously, is that going to be the same for any other segment on that graph? No, but you could write an expression for every single one of those if you wanted to, if it asked you to, okay? So that would be my velocity. That was equal to negative 20 times t minus 10. Since our variable's actually in terms of t, I'll put a t there, okay? And then my last one is distance. So distance from the ground. Again, from that interval of 10 to 12. So the distance is going to be your integral from 10 to 12 of my velocity. Let's see. I also want an absolute value around this. So we're talking about the distance. Yes. Very good. Questions on either of those three? Yes. So I need to not have these. And then I need to add I need to add the position at times 10. Do we agree with that? That looks better. Okay. We'll do the multiple choice and then we'll end with the calculator part, okay? So these next two multiple choice questions, I'm gonna let you guys try out by yourselves first. It's kind of asking you, do you know the difference between distance, displacement? What do you need to have when you're solving for certain things? But I will give you the kind of hint that they might try and trick you a little bit, okay? So you might not need all the information that is given to you in the examples for 3 and 4, okay? So I'm gonna give you a few minutes to try that out and then I will go over those two with you before we do our calculator problem. All right, so example 3, the question that we were asked is, what is the total distance traveled between 5 and 10 seconds? The total distance traveled. Okay, total distance, if we're talking about distance, we're looking at what?
Just between 5 and 10.
Yeah, between 5 and 10, but we're looking at the absolute value, right? I don't care if it's below or above the x-axis. I'm just going to add those values underneath the curve together. So what is my answer going to be for example 3? C, that is exactly correct. Okay, letter D, what's letter D actually finding? The displacement. Yep, that's exactly right. And then what's letter B actually finding here if I integrate this with the 6?
From 0 to 10?
It's the distance that it's the position that the particle has reached by the 10 seconds. So yes, you're adding in that initial part from the time t equals 5, which was 6 meters. So if I started at 6 meters and then I add in how far apart I moved, that's going to be your total position there at that point. Okay? All right, let's look at example 4. Example 4, question that we were asked is, what is the particle's displacement between t equals 2 and t equals 9? So if we're talking about displacement, which two answers could I get rid of right away? C and D, because that is absolute value. So that's going to be talking about your distance, right? So then we're between A and B. Which one is it going to be? It is actually letter B, because all I care about is between time t equals 2 and t equals 9. I don't care about where it started at, okay? So you don't need to include that value. It is just going to be letter B, okay? All right, we are going to not do example 4, okay? So you can cross that out. It is kind of a good check to make sure you kind of understand what this expression is talking about. If you're not sure, that is where this next slide comes into play. Let me show you this next slide here. Okay, this should be on your notes as well. It's literally an entire page of just notes. Okay, we've talked about all of these things already, but it's just kind of a good spot to go if you're confused with like what information you're given or what you're trying to find based on the stuff that you have. But it kind of talks about like these few up here talk about, you know, your particle at rest, if it's moving to the left, moving to the right. What does that mean about your velocity over there? Here's your formula for average velocity. Remember, instantaneous velocity, that's going to be your derivative at that point, at that certain point there. It talks about increasing, decreasing. It talks about a bunch of different things on here. We've got the distance and displacement formulas down here. But it's just a good spot to go if you're not sure what to use, okay, on your homework that you're trying out. Okay, so we're not going to write anything else on here, but this is there for you guys to look at if you want, okay? All right, now we'll go to the calculator one. After we have this one's going to seem super easy compared to what we were doing. So the first one, this first example here is just asking us about displacement and distance. So if we're given a table, we're given a table of time and then position, okay, where x of t is measured in carpet squares. Question 1 says, how far was your teacher's ending position from the starting position at time t equals 0 to time t equals 4? So how far, or what's the distance between the starting and ending position? So between 2 and 18, what's the distance between that? 16. 18 minus 2 is just 16. So that would mean that your distance between those, 16 carpet squares. Okay. This is technically, I keep saying distance, but it's actually what? Displacement. The next one says, what is the distance that your teacher traveled from t equals 0 to t equals 4? Well, I need to find what the distance between each of these values is. So from 2 to negative 2, how many carpet squares are those? 4. From negative 2 to 0, that would be 2. 0 to 2, there's 2. From 2 to 18, there is 16. So if I added all of those together, that's the total distance that was traveled. So that would give me, what, 24? Okay, distance versus displacement. Okay, I had technical difficulties last class period because I accidentally kept deleting my y equals. So we are all going to be very careful to not delete it, okay? Very careful. So we've got a particle, and it's looking at from time t equals 0 to time t equals 8, and we've got a velocity function here. Okay, nice and gross with natural log signs and all that kind of stuff. One thing you're going to want to make sure on is that you are in radians on your calculator, okay? We are also given that the initial position, s of 0, is at negative 3. So that's going to come into play for one of these examples, part A, B, and C, and D. One of them it'll come into play, okay? The first question asks us to find all of the values in the interval for which the speed of the particle is 5. So if we're looking at speed, that means I'm looking at the absolute value of my velocity function. Okay, so I'm looking at when does that absolute value of x, or absolute value of t, equal 5. That's what we're trying to find out. Which, if I set that thing equal to 5 and I try and solve that by hand, it's not going to go too well, right? So we're going to have to plug into our calculator. In y1, I want you to type in the absolute value of this whole function. And then in y2, I want you to plug in 5. Okay, if you don't know where the absolute value bar is on your calculator, if you go to math and then numbers, I think it's the first option in there. Okay, so I'm going to give us a minute first to plug this in, see where it intersects, and then we'll check our answers. Okay, so plug both of those in first. I will show you up on the TV here as well what I get when I do it. So we're looking at the interval from 4 to 7 on our graph. So you're going to do that second calculate to intersect to find what those two values are. And then I'm going to plop a picture in here of what you should end up getting so you can check with me as well. Okay, so the picture, let's see. Oh wait, that's just one of them. Oh, that's not what I wanted. Okay. if you look closely here, your two answers that you should have gotten are 5.62137 and 6.52026. Okay, so I'm going to give you a few more minutes to try and figure those out if you need it, and I'll be walking around to help if so. Okay, so those are your two answers for the speed. What was the question? When the speed was equal to 5. So it's at that time 5.621 and 6.520. The next question asks us to write an expression involving an integral that gives the position s of t, and then use that to find the position at time t equals 3. So if we're given velocity, we want to find position, what am I going to have to do? Integrate it, right? So I'm integrating from 0 to 3 of my velocity function. But then I need to add where we started. We were given that initial value of -3. Okay. So from 0 to 3 of my velocity function, and then I need to add in my initial position. So we're going to add in my s of 0, which is actually just -3. Okay, so this is going to equal my position at time 3. Okay. So if I go ahead and plug this in my calculator very carefully, if we still have that typed in y1, it should not be too terrible, because all you're going to do is you're going to type this left-hand side, but instead of typing in that entire function again, we can just grab that like value from y1. I forgot what button it is. So we got to make sure in my y1 that I take the absolute value bars off. So delete the absolute value bars so you only have the velocity function. Okay, then I can go ahead in my calculator, go math option 9. And then I can plug in my integral from 0 to 3 of y1. And then plus -3 or -3. And then if you plug that in, it should give you approximately -6.263. Okay, so I'll give you guys all a minute. Make sure you can get that answer on your calculator. However you want to do it. If you have to plug in the whole thing, that's fine. Or you can use that alpha trace to grab that y1. Okay. Part C. Part C asks us a question that we're going to answer. It says to find all the times at which the particle changes direction, and then to justify our answer. Okay. So we're looking, if we look at our velocity function, if we just look at the graph, where are we going to find where it changes direction? When it crosses, right? So when the velocity is equal to 0. So that's what we're looking for on our graph. But we are going to graph v of t, which you should already have in there if you deleted the absolute value. So you're going to graph v of t and see where the velocity is equal to 0. Okay, so if you go and graph v of t, then you're going to find your zeros, which is using your calculator second trace again. And then it's option 2 for 0. Okay, so graph v of t, find your two zeros, because we're looking at the interval from 0 to 8 here. There should be two answers. I'll put a picture up here of what I got for those two so that you can see if you are correct, okay? So our two answers for part C are 6.127 and 2.341, okay? And then our last answer, last question, part D, asks us where is the particle increasing is the particle increasing or decreasing at time t equals 7? And then give a reason for our answer. So if I look at my graph at t equals 7, there's two things I could look for. I could either look for is it moving away or towards the x-axis? Or we can look at, is the velocity and acceleration the same or are they different? Okay, so either kind of one of those thought processes is fine. But let's go ahead and I'm going to grab the graph and plop that in here, and then we can talk about is it increasing or decreasing at that point. So here's my graph of v of t. So at time t equals 7. 7 is right here. At time t equals 7, we got to figure out what is happening with my particle, if we're speeding up or slowing down. So 7, if I kind of draw that down here, it's at that point right there. So two things I can look for. I can either say, okay, we are moving away from the origin. So if we're moving away from the origin, what's happening? Speeding up, yep, or increasing. So moving away. Oh. Or we can look at my velocity and acceleration. So this is my velocity function. So I know v of t is negative. And if I looked at the slope in that red section, the slope of all of those would also be what? Negative, right? So since those two signs match, we also know that it is increasing. Okay, so it's increasing at times t equals 7. Any questions on the calculator stuff? That was a lot of calculator things to remember. Wonderful. Okay.